Okay, so we're going to proceed with quarter 4, week 5, module 3, chemical reaction. From the time we get up in the morning to the time that we sleep at night, chemical changes are taking place within us and outside of us. Plants grow through photosynthesis. Foods that we eat are digested by the body. Meals corrode. Raw materials are being converted to useful products. New medicines are being developed. More versatile and most cost-effective materials are being made. First, you need to answer the free test, which is you have to answer 1 to 5 and choose from the letter of the correct answer. For numbers 6 to 10, you have only to write true or false. For numbers 1 to 10, you have to write only the letter of the correct answer on the first column. If you're going to look at your answer sheet for the pre-test for module 3, write your answer inside the box. For learning test 1, what I know, read each test item carefully, classify the following situation as physical or chemical change. Number 1, burning gasoline. Number 2, breaking glass. Number 3, digesting food. Number 4, evaporation of water. 5, making ice cubes. 6, making ammonia from nitrogen and hydrogen. Learning task 2. Read and try to understand the short discussion about chemical reaction. Chemical and physical changes are essential to man and the environment. Understanding how to differentiate between chemical and physical change is an essential skill that secondary school learners must acquire. A chemical change is the change of a substance into a new one that has a different chemical identity. Chemical reactions result in the production of new chemical substance. A molecular level chemical reactions involve making or breaking bonds to create new chemical substance. A chemical reaction is usually accompanied by easily observed physical effects or evidences such as number 1, a change in color. Number 2, a change in odor. For example, silver to reddish brown when iron rusts. Number 3, the change in taste. 4, the emission or production of heat and light. 5, the formation of precipitate or insoluble particles in the process of precipitation. 6, the evolution of gas or effervescence. Effervescence often appear as bubbles in liquids. 7, and temperature change, such as the production exothermic or loss endothermic of heat. Change in volume or shape. Number 9, change in composition, like paper turning to ash when burned, or the decomposition of organic matter like rotting food. Oxygen is vital to life. One interesting reaction which involves oxygen is the production of fire. Fire has fascinated people for so long that the ancient people even regarded it as one of the earliest elements. Fire was so important to them, and they describe it as an element that changes everything. The earliest theory about burning was the phlogiston theory. This theory was by George Ernst Stahl in the 17th century. Stated that when a material burns, it releases a substance known as phlogiston. And this theory was accepted for a very long time. Anton Lavoisier, through his careful observation from his experiments, debunked the phlogiston theory, as he discovered that instead of releasing a substance, phlogiston, a material accurately burns as it reacts or uses with oxygen. This is now known as the theory of oxidation, and this is accepted up to this day. And that is Anton Lavoisier with his theory of oxidation experiment. Chemically, combustion is more than the reaction of a fuel, wood, oil, gasoline, etc. with oxygen. For combustion to take place, there must be a fuel and oxygen gas. However, this reaction often requires activation energy, which can be provided by a spark or source of energy for ignition. Fuel, oxygen, energy are the three things make up what is known as the fire triangle that should be present in proper conditions and proportions, and any of them being absent means that combustion will not take place. And here is the fire triangle. We have oxygen, heat, and fuel. In our country, we are reminded that March is a fire prevention month, as this month signals the start of summer, the season when countless fires break out all over the country. An ounce of prevention is better than a pound of cure is a motto we all need to remember. Various materials act as fuel to sustain fire, so various fire prevention and control measures are given through information dissemination by the government to prevent us from harm. Learning Task 3, Activity 1, What's in a reaction? Objectives, distinguish between reactants and products. B, write a chemical reaction. Equation, sorry. Note, reactants are substances that are used up to form a new substances in a chemical reaction. Directions. The following are samples of the chemical reactions. Fill in the table below with reactants and products. Below each number, write the symbol or formula. So these are the statements. The first number is done for you as an example. You may use it as a guide to answer numbers 2 to 5. Direction. Looking at your answer sheet, reactants and products are listed already. Write the formula or symbol enclosed in parentheses. So I have already given the reactants by writing their elements or compounds. All you need to do is write the formula. Let's proceed with the symbols used in chemical equation. There are other symbols used in writing a chemical equation. So the plus sign shows a combination of reactants or products. An arrow pointing to the right means to produce, to form, or to yield. Those in parentheses with the small letter S, L, G, A, Q, S for solid, L for liquid, G for gas, AQ for aqueous, substance dissolving water. Two arrows pointing left and right means a reversible reaction. An arrow with a triangle above indicates that heat is applied to the reaction. An arrow with a PT, a formula written above or below the yield sign, indicates it used an element or a compound that is a catalyst or solvent. A chemical equation is a chemist's shorthand for a chemical reaction. The equation distinguishes between reactants, which are the starting materials, and the products, which are the resulting substances. It shows the symbols or formulas of the reactants and the products. The phases are solid, liquid, gas of these substances, and the ratio of the substances as they react. Let's proceed with learning task 4. Use the symbols and formulas in table 1 and symbols in table 2. Write the chemical reaction using these symbols to complete the chemical equation. So in here, Number one is a sample already. Now, under every blank, there are choices provided inside the parentheses. You only need to choose one answer and you have to write it on the blank provided. For the enrichment activity, chemical formula writing. A chemical formula is an abbreviation for the name of a compound. The actual formula, made up of symbols and elements with proper subscript. A subscript indicates the number of atoms. Valence is the outermost electron. Oxidation number is the apparent charge of an atom in a compound. The actual charge when electrons are transferred from one atom to another to form ions. These are the rules in writing chemical formula. Place the oxidation number ON over the symbol for the element or radical. Crisscross or cross multiply the oxidation number to form subscript but drop the sign. For radicals, enclose it in parentheses. If the subscript is 1, drop the number. If the subscripts are numerically equal, no subscript will be used. If the subscripts are not in their lowest terms, reduce the lowest term by dividing each subscript by the greatest common factor. Here is a sample. Aluminum chloride has positive 3. For aluminum, chloride has negative 1, or chlorine. So this is the oxidation number on the upper right-hand corner. In the upper right, aluminum is positive 3, while chlorine is negative 1. Then we cross multiply these two oxidation number, so we arrive at aluminum trichloride. Another example is calcium sulfide. Calcium has positive 2, sulfur is negative 2. We crisscross them, and since both of them has 2 as their oxidation number, since both of them are the same, we drop them both. We get their common GCF. So we write it as calcium sulfide, or CAS plainly. Learning task 5. Let's try this. Determine the chemical formula for each combination. Write your answers in each box. The first one is done for you. So all you have to do is underline your answer. Sodium has positive oxidation number. Chlorine has negative oxidation number 1. Oxygen has oxidation number negative 2. Sulfur has negative 2 oxidation number. So for magnesium, we have positive 2. For calcium, we have positive 2. For iron, we have positive 3. So all you need to do is underline your answer. So you have to choose between only one, between the two. Factors affecting reaction rate. Gas bubbles that are frequently produced when a tablet dissolves in water are often not seen by learners as a new substance. The formation of bubbles is often the result of a chemical change, except in the case of boiling, which is a physical change. Based on the experiment, it was evident the effects that acid has on eggshell or carbonate. Similarly, in nature, the effects of acid rain has on limestone buildings. Thus, understanding the detrimental effects of acid rain for buildings, as well as forests, etc. Global warming is usually the rapid rise in the average global temperature on Earth. The main cause of global warming is the drastic increase in the emission of carbon dioxide by the burning of fossil fuels. There is a result of chemical reaction as evolution of gas. Acidic gases are produced when fossil fuels such as coal and oil are burned in power stations, factories, and homes. These acidic gases such as sulfur dioxide and nitrogen oxide react with water molecules in the atmosphere, causing rain and snow to become more acidic. This acid rain then causes harm to the forests, lakes, oceans, and marble or limestone buildings. For learning task 6, observe some banana cue vendors. What are they using to sweeten their product? Are you familiar with samkaka? It is a sweetener in a compact sugar form which is formed from sugarcane. It is commonly used for cooking purposes where it gives much sweeter flavor for its being pure. Ask some banana vendors about what they usually use in Tony sugar under banana Q and why they prefer to use it than the other. Write the letter of your answer before each number. Choose your answer from the choices below. A, particle size or surface area. B, temperature. C, catalyst. D, concentration. What is the factor to consider? And although Sangkaka is much tastier, some banana cube vendors using crystallized sugar than Sangkaka in their cooking. Number two, what is the factor that speed up the reaction using crystallized sugar than big chunk of Sangkaka? What factors, number three, what factors speed up the reaction for this activity? For quarter four, you have to answer the post test, which is 1 to 20. Please write the letter of your answer inside the box of the answer sheet. That's the end.